Greetings to all. In this video, I am going to solve some of the assignment problems in NPTEL. The subject is Fundamentals in Electrical Engineering. Fundamentals in Electrical Engineering. Okay, first of all, I am going to solve the problem number 1. The value of dependent voltage source and the current flowing through 4 ohm resistor. In this circuit, it consists of two loops. This is loop number 1 and this is loop number 2. See here, first of all, I am going to consider the loop 1 and then I have to apply the KVL. In the loop number 1, so I have to mark the current direction. Here first consider the voltage source. The current is flowing from negative to positive terminal, voltage rise. Here positive to negative terminal, voltage drop. Again positive to negative terminal, again voltage drop. So first I have to consider the loop number 1. Then I have to write the equation using Kirchhoff's voltage law. The equation is voltage rise 10. Voltage drop is indicated by minus V0. Again voltage drop minus V0. That is equal to 0. 10 minus 2 V0 equal to 0. V0 equal to 10 divided by 2, that is equal to 5 volt. This is the value of dependent voltage source. Next, I am going to consider the loop number 2. This is the next loop. Here also I am going to apply the KVL. So this is negative to positive voltage rise. Here in a resistance always voltage drop. The current flowing from positive to negative. Here the negative to positive, again voltage rise. Now I am going to write the equation. So first V0 is what? 5 volt plus 5. Here positive to negative, so that is minus 4i. Here again negative to positive plus 2 equal to 0. So what is 4i? 4i equal to 7. I is equal to 7 by 4, that is 1.75. So the answer is 5 volt and 1.75 is the correct answer. Next problem, in the figure shown, n is equal to 100. Total number of resistance given is 100 and each resistance having the value 2 ohm. Here the question is to find the voltage drop across 100 ohm resistor. I have to consider n is equal to 100. I am going to find out V100 ohm. Okay, 100 resistance. Okay, so V100, that is equal to, here I have to use the voltage division technique. So V, that is total voltage into the same resistance, that is R100 ohm, divided by the total resistance from R1 to R100 ohm. Okay, what is the voltage? Voltage given is 50 and what is R100? Each resistance 2 ohm. Here total number of resistance is 100 and each resistance 2 ohm. So what is the answer? 2 cancel, 50 100, that is 1 by 2, or the answer is 0.5 volt. Is the correct answer. Option B is correct. Next, the problem number 3. In a problem number 3, current through 1 ohm resistor will be. Here the current source 10, the 10 ampere current source that always takes the low resistance path to flow. Here which one path having low resistance? Here the resistance equal to 0. This is the low resistance path. So what about the current flowing here? The current flowing here is 0. So there is no current flowing through 1 ohm resistor. The answer is I1 ohm equal to 0 ampere. So that is the correct answer. Then fourth problem, in a given circuit, output voltage V0 can be written in terms of Vs. Here they have asked the output voltage V0. For finding out output voltage V0, we should know the current flowing through RL. Then only we can find out the output voltage V0. So how to find out IRL? To find IRL, we should know what is the total current in the circuit. So for finding out the total current in the circuit, we should know the total resistance. So first I am going to find out the total resistance. For finding out the total resistance, here see R2 and RL both are connected in parallel. The combination in series with R1. So in this way I am going to find out the total resistance in a circuit. So R2 and RL that are connected in parallel first, parallel. So what is the net resistance? R2 into RL, the whole divided by R2 plus RL. So this combination is in series with what? Series with R1 again. So what is the net R resistance or total? R1 plus R2 into RL divided by R2 plus RL. Here this is RL. Okay, this is the total resistance. Okay, next I am going to find out the total current. V divided by the total resistance is what? R1 plus R2 RL divided by R2 plus RL. Okay, now current is over. See, the same current is flowing through this resistance I1, and this is divided into two parts. One of the current is flowing through R2 and next current is flowing through RL. I am going to find out IRL only. Okay, IRL is what? Here I am going to use the current division technique again. The net current or total current into the opposite resistance. Which one is opposite here? R2 is the opposite resistance divided by total resistances R2 plus RL. Okay, now I am going to substitute I here. So that is not I1, I here. So B divided by R1 plus R2 RL divided by R2 plus RL into R2 divided by R2 plus RL. Okay, this is the equation for IRL. Next, what is our aim? To find out V0. So, what is V0? I into RL into RL. So, V into RL. So, R2 into RL. I am going to write this like R2 plus RL, the whole divided by R1 plus R2 RL divided by R2 plus RL. So this is the correct answer for V0. So V0 is written in terms of V here. So D is the correct answer. Next I am going to explain the equivalent resistance for the given network across the given terminal. First of all, I am going to redraw the circuit. Here we are having the star arrangement. First of all, I am going to convert. This is star arrangement. No, I am going to convert the star into equivalent delta, and I am going to redraw this arrangement now. Okay, I am going to redraw it. So first the two resistances here, and next how to draw this. This is the center one resistance. Here I am going to redraw the star like this. Okay, next I am going to put all the values of resistances. Here this is R equivalent. Here 2 ohm, 2 ohm. Here 1 ohm, 1 ohm and 1 ohm. Next, what I have to do, first of all, this star is converted, this is star network is converted into equivalent delta. Okay, I am going to draw the equivalent delta above the star. Okay, this is the delta connection. Here I am going to find out the value for delta connection. Okay, how to find out the delta value? delta value is R is equal to, here the opposite resistance. Which one is opposite for this one? That is 1 ohm. Here multiply two resistances together. 1 into 1 plus 1 into 1 plus 1 into 1. So 3 divided by 1, 3 ohm. Now I get the value. Now again I am going to redraw the circuit. I am going to redraw the circuit again. Now I get the delta value from the star value. Okay, redraw it again. Okay, here I have to substitute the values also. Here the value is 2 ohm. Here also 2 ohm. Here each resistance may be 3 ohm. Okay, so this is R equivalent. Okay, now see here the 2 ohm and 2 ohm. These 2 ohm are connected in parallel. These 2 ohm are connected in parallel. Okay, so now I am going to find out the net resistance. Okay, find out the net resistance. So 2 into 3 divided by 2 plus 3, that is a parallel combination, 6 divided by 5. So now I have to redraw the network. Here 6 by 5, 6 by 5. This is in series with 3 ohm resistor. Okay, now I have to redraw this. So 6 by 5, 6 by 5, here 3 ohm. Okay, so this is the R equivalent. Okay, now so both are series, no. So 6 by 5 plus 6 by 5. What is this one? That is 12 by 5. So this is the 12 by 5 ohm. So this combination may be 12 by 5. Now the 12 by 5 and 3 ohm is connected in parallel. So 12 by 5 into 3. 12 by 5 plus 3. So what is the answer now? That is 6 divided by 5 divided by 5 3s are 15. 15 plus 12, 27. 27 by 5. 5 5 get cancelled. So 36 divided by 27, that is 4 divided by 3. The answer equal to 1.33 ohm. So 1.33 ohm in between 1.30 and 1.35 ohm. C is the correct answer. So next problem, the voltage difference between A and D is, first of all, I have to connect the A and D terminal. Okay, A and D. Next what I have to do, have to mark the terminal PAD. Okay, so first of all, I am going to find out V2 ohm. V2 ohm is the unknown voltage here. Here I have to consider the current direction is clockwise direction. So first here, this is the 20 voltages, voltage rise. And here positive to negative voltage drop. And here also voltage drop. Now I am going to write the equation. Okay, what is the equation? 20 voltage rise minus this is the voltage drop, again 5 voltage drop, so that is equal to 0. So V2 ohm equal to 20 minus 5, that is the 15 volt. Now I have to substitute the 15 volt here. Then next see the 4 ohm. Here V4 ohm. I am going to find out V4 ohm. So here this is the voltage rise. I am going to consider the current direction as clockwise. Voltage rise. This is voltage drop. Again voltage rise. Now I am going to rewrite the equation here. So I have to mark the current direction also. First one is voltage rise 15, then voltage drop V4 ohm, again voltage rise, that is the 1 volts equal to 0. So V4 ohm, voltage across 4 ohm is 16 volt. Now I have to mark the voltage here 16 volt. So this is the closed loop. In this way the closed loop is formed. Okay, this is the closed loop. Okay, now I am going to write the entire equation using KVL. So first of all, this is the current direction. No, the current is negative to positive, voltage rise VAD. And then see here, this is positive to negative voltage drop 16 volt, and see here this is also positive to negative voltage drop 5 volt, and then see here positive to negative, that is again voltage drop 10, that is equal to 0. So VAD, that is minus 16 minus 5 21 10 31, minus 31 equal to 0, or VAD equal to 31 volt. That is the correct answer. Problem. The current through 4 ohm resistance in the circuit is given. Circuit given will be. Here already we got the answer here, that is 16 volt. Here the question is to find out the current flowing through 4 ohm. So what is I4 ohm? I4 ohm is voltage across it divided by 4. So what is the voltage? 16 voltage. Already we have got the answer, divided by 4. That is 4 ampere. What is the answer? The option number 1 is the correct answer. Next, what will be the current flowing through branch AB? For finding out the current flowing through branch AB, first of all, I have to reduce this network. Okay, before that, first I have to draw the current source here. That is the 20 ampere current source. Then the parallel resistance, that is 4 ohm. Again, the resistance, that is 2 ohm. Okay, then see here both are connected in series combination. What is the net? That is 2 plus 2, 4 ohm. And this 4 ohm and this 4 both are connected in parallel. So 4 into 4 divided by 4 plus 4. So what is the answer? 16 by 8, that is 2 ohm. Okay, now I have to redraw the circuit. Here the net is got, it is 2 ohm. Okay, now first of all, we are going to find out the current here. In order to find out this current, first we should know what is the current flowing through this combination. Okay, for this, I am going to apply the voltage current division technique. So what is the current? Current division technique, the total current into, this is the opposite resistance is 4 divided by 4 plus the total 2 plus 2, 4 ohm. Okay, then 20 into 4 divided by 8. So 1 by 2 or 10 ampere. So what is the current here? That is the 10 ampere current. Okay, no. This is 10 ampere current. Then this 10 ampere current can be divided into two parts. Okay, one of the current is, you have to find out the current. So how to find out this? 10 into here to the 4 ohm, that is opposite resistance, divided by total is 4 plus 4, that is 10 into 4 by 8. So 1 by 2, that is the 5 ampere. That is what? 5 ampere. Okay, this current may be 5 ampere. So the current 5 ampere is correct. Option C is the correct answer. Next, for the given circuit, voltage across the current source will be. Here already we got the answer, that is 10 volt, 10 ampere. Okay, here I am going to consider the assumed direction as clockwise direction. So then here what is the value? Be 20 ampere. Here positive, negative. Okay, now I am going to apply the Kirchhoff's voltage law for this loop. So V20 minus 40, 20 ohm minus 40 equal to 0. So V20 ohm equal to 40 volt. So V20 ohm equal to 40 volt is the correct answer. So option A is correct. Next, the voltage across 5 ohm branch will be. Here, how to find out this? I'm going to use the nodal analysis. For applying a nodal analysis, first of all, I'm going to mark the corresponding nodal voltage. Here, this is the node 1, the corresponding voltage is V1. This is the node 2, the corresponding voltage is V2. Then I am going to assume the direction of current. All the currents are flowing away from the junction. First of all, with respect to nodal voltage V1, I am going to write the equation. So V1 minus 100 divided by 5 plus V1, here 0 voltage, minus 0 divided by 3. Then V1 minus V2 divided by 3 equal to 0. So V1 of 1 by 5 plus 1 by 3 plus 1 by 3 plus V2, minus V2 by 3 equal to 0. So take the LCM here. So V1 of 15, here 3 plus 5 plus 5 minus V3 by 3. 5. So you have to convert this into 15 into here 100 by 5. So 100 by 5 is what? 20. Okay, here 20. Now V1 of that is 5 plus 5, 13 V1 by 15 minus 5 V2, 5 V2 divided by 15 equal to 20. Okay, 13 V1 minus 5 V2 equal to 300. This is the equation number 1. And next, with respect to V2, I am going to write the equation. Okay, V2. So V2 minus V1 by 3, this is the first one. Next V2 minus 0, okay, V2 minus 0 by 3. Then here assumed direction is away from the junction and actual direction is flowing towards the junction. So how to write this? V2 minus 50 divided by 2, that is equal to 0. So first of all, I have to write V1 by 3 plus V2 of 1 by 3 plus 1 by 3 plus 1 by 2, that is 50 by 2. Okay, then you have to take the LCM. So LCM is 6. So you have to convert this also into 6. So minus 2V1 by 6 plus V2 of here 6, 2 plus 2 plus 3. Okay, here 25. Okay, what is the next one? That is minus 2V1 plus 7V2. Here you have to multiply 6 with 25. That is 150. Okay, two equations we got. One is 13V1 minus 5V2 equal to 300. And second equation is 150. This is equation number 1. So 1 is multiplied with 7 and 2 is multiplied with 5. We get 7 3s are 21. That is 91 V1 minus 35 V2 equal to 2100. And here 2 into 5. So minus 10 V1 plus 35 V2 equal to 750. Okay, what is the answer? That is 81 V1. These two are get cancelled. 2850. Okay, what is V1 now? 2850 divided by 81. So what is the answer now? The answer is 35.185 volt. This is the answer. Okay, but our answer is you have to find out the voltage across 5 ohm branch. So how to find this 5 ohm branch voltages? 100 minus this one 35.185, that is equal to V5 ohm, isn't it? So V5 ohm equal to what? Have to find out the value using calculator. 100 minus 35.185. So what is the answer? 64.815. 64.815, and the answer is volt. In volt, that's the correct answer. That's option B. Okay, next. From the given circuit, the amount of current that will flow 2 ampere 2 ohm towards 50 voltage sources. Okay, source will be. Already we got the answer for V1. Okay, isn't it? V1 equal to what? 35.185 volt. Okay, next I am going to find out V2. For finding out V2, I am going to take the next equation, minus 2V1 plus 7V2 equal to 150. Okay, so substitute the value V1 here, 35.185 plus 7V2 equal to 150. Okay, 7V2 equal to 150 plus 2 into 35.185. So 35.185 into 2. That is equal to what? 70, 70.37. 70.37 plus 150, no, that is equal to 220.37. 220.37 7v2. What is v2? v2 equal to 220.37 divided by 7. What is the answer? 31.48 volt. 31.48 volt is the correct answer. That is v2. But what's the question? The current that will flow through 2 ampere towards 50 volt source. So what is the voltage here? That is V2. So how to write the current 2 ohm, that is V2 minus 50 divided by 2. So now 31.48 minus 50 divided by 2 is the correct answer. So 31.4 minus 50, that is divided by 2. That is, what is the answer? Minus 9.25. Minus 9.25 ampere is the correct answer. So option D is correct. Next, what will be the voltage across 5 ohm in the given circuit? Have to mark the voltage here. So this is the nodal voltage V. Have to apply the nodal analysis here. So all the currents assumed, all the currents are flowing away from the junction, and here as actual direction is towards the junction, but assumed direction is away from the junction. Now I have to write the equation. So V by 3, that is V minus 0 by 3, V minus 0 by 5, the ground potential is 0. So V minus 0 by 1, here both the directions are opposing. So minus 10, the first one also like this, minus 10 equal to 0. So now 1 by 3, V of 1 by 3 plus 1 by 5 plus 1 equal to 20. So now I have to take the LCM here. So 3 5s are, 5 3s are, 1 15s are. That is equal to 20. So V is equal to 20 into 15 divided by 23. So I have to find out the answer. 20 into 15, that is divided by 23, that is 13.04. 13.04 volt. That is the correct answer. That is in the option B. Thank you. Have a nice day.